Good morning. This is Ms. Billerbeck, and we are going to talk about 3.6 a little more in depth in regards to the residual plots. So first, let's talk about what a residual is again. So a residual is the difference between the y value of the data and the corresponding y value of the line of best fit. So our data scatter is in the green. And so if we have the line of best fit here, the data scatter above the line of best fit would have a positive residual. The data scatter below the line of best fit would have a negative residual. So your predicted value from the line of best fit is actually on the line of best fit, and the actual value are the actual points of the data scatter. So we would call the equation would be residual equals actual minus predicted. So let's take a look at how we might use this. So a business owner has a flight school and collected enrollment data for 7 years and wanted to use a line of best fit to predict future enrollment for planning purposes. So we have 7 years here, and the actual data is right here. So the line of best fit generated in a linear regression was 1.44x plus 877. So these are the predicted values using 0 through 7 as inputs using that line of best fit. To calculate the residual, we use residual equals y actual, which is the actual data, minus y predicted, the data of the line of best fit. So we subtracted 830, or we took 832 and subtracted 877 and got a negative residual. So this point is below the line of, the actual value is below the line of best fit. And we continue to subtract all of the predicted values from the actual. Sometimes we would have positive residuals, and sometimes we would have negative residuals. So let's take a look at what we actually get when we put this into a Desmos residual plot. All right, so when we see this, we have the 7 years here, and we have just the residuals right here. So we see that we have a bit of a pattern going on here. Now, if we don't have any experience, we don't know if this is a good residual or not. So let's take a look at what might be a good residual. So this one is classified as a good residual. So if we look at that, the data is pretty evenly balanced around the line. Okay, let's take a look at one that might not be a good residual. So this one, it has a bit of an M pattern to it, which makes me a little suspicious that the regression done on this particular data for the line of best fit or curve of best fit was not the appropriate regression. And then this data has a bit of a parabolic shape or U-shaped. And so this regression could have had a different model than a linear regression if that's what they used for this. Okay, so this is not a good regression versus this is a good regression. We also have something that looks like this. This isn't so bad right here. That's a pretty good regression as well. So let's take a look at another Desmos and see if we can do better with our line of best. Well, let's go back to the residual. So we see we definitely have a pattern here. So it makes us a little suspicious that perhaps our regression wasn't the appropriate one. So let's take a look at other regressions. So if we look at, this is our data here with the actual data, and this is a linear regression, y approximates to mx plus b, and we see, oh, we have an r of 0.1. That's not very good. So if we look at this regression of the data, this is our linear regression right here. Okay, but we see that the data is kind of curving around like this. So it almost works with a quadratic, but it starts going back up again right there. So we can see that this is a quadratic. So if we look at the quadratic, r is 0.78, the r squared is 0.78, which is similar to the r. And then if we look at the cubic, this is a cubic curve, the one that goes from bottom and then goes way up. It fits pretty well. And look at that r, 0.9297 for an r squared. So this data is really not a linear regression. It's not suitable for linear regression. It's better for a cubic regression. Okay, so basically that is what you need to know for regression. Choosing a linear regression, you do want to look at a good residual, which now we know that this is our good residual plot, and we want a nice balanced plot for our residuals. We also want a very high R of either in the 0.8s or above, 0.8 to 1, or negative 0.8 to negative 1 for an R value to know if our regression model is the appropriate one. All right, so that is it for the residual plots. I hope that helps. Have a wonderful day. Bye-bye.